Okay, so part one of solving equations. These equations will be polynomial equations, and in part one, we're going to solve these polynomial equations by factoring. So if you hadn't had factoring in a while, you may want to go back and review your factoring rules. Um, how to factor trinomials, the GCF, difference of two squares, difference of two cubes, sum of two cubes, and so on. So there was a whole chapter in a previous course that dealt with factoring. Okay, so remember though we are talking about polynomials. So just review. Remember a polynomial equation is where you have two polynomials equal to each other. So for example, now remember polynomial is one or more monomials. So you have this binomial on this side and this monomial on this side. So you have two polynomials equal to each other. So this is a polynomial equation because of the equal sign. Here's another polynomial equation, and here's another polynomial equation. And so when solving a polynomial equation, and we're going to do this by factoring, you want to make sure that it is in general form. And remember, sometimes in a previous course, we call this standard form. And so what we mean by standard or general form is that we need 0 on one side. So you're going to bring all the terms to one side and 0 on the other side. And then once you do that, once you put it in general or standard form, you're going to factor the polynomial, and then you're going to use, remember, the 0 factor property. And so that's where you're going to set each factor equal to 0. Okay, so these are examples of polynomial equations. All right, so let's look at some examples. So remember, you're going to solve these polynomial equations by factoring. So you're going to put it in standard form first, put it in descending order, and then you're going to use the 0 factor property. Okay, so number one. All right, suppose we had 3x to the fourth minus 48x squared equal 0. So 3x to the fourth minus 48x squared equals 0. So notice it is already in standard form or general form. So it's already in that form, general standard form. It is in descending order. Okay, so it's in descending order. So remember, going from largest exponent to smallest. And now we're going to factor. All right, so remember, when factoring a polynomial, you look for the GCF first. So is there a GCF other than 1? And there is here. So in this case, I could factor out a 3x squared. And so when I factor out the 3x squared, to make sure you still rewrite this as an equation, so that's equal to 0. So when you factor out the 3x squared, you're going to get 3x squared times x squared is 3x to the fourth. So remember, you're using the distributive property. So 3x squared times x squared is 3x to the fourth minus 48 divided by 3 is 16, so minus 16. And then this is x squared, you've already factored, so you just need 16. So 3x squared times 16 times a negative 16 is a negative 48x squared. All right, so that's where I'm at. So the first thing you have to do here was factor out an x squared. Now, you want to factor completely. So if you notice this x squared minus 16, that's the difference of two squares. So I can factor this further. So I get 3x squared times x minus 4 times x plus 4 equals 0. So remember, you need to factor completely. So if you don't remember your factoring rules, you need to go back and review those. So the first thing you have to do was, when factoring completely, is look for the GCF. So I took out a 3x squared. And remember, you always must do the GCF. If you had not taken out the 3, you probably would not have noticed right away that this was the difference of two squares. So if you had not taken out the 3, at some point you would have had to factor out the 3. Okay? All right, so now what we're going to do is we're going to set each factor equal to 0. So I'm going to set this equal to 0, this equal to 0, and this equal to 0. So that's where we're using the 0 factor property. The 0 factor property. So I set each factor equal to 0. So I get 3x squared equals 0, x minus 4 equals 0, and x plus 4 equals 0. So I set these 3 factors equal to 0. Now to get x by itself here, now you could look at this and determine what x is. So 3 times what number squared is going to be 0. So again, so you're trying to solve this equation. So by inspection, you could figure out what this is. So 3 times 0 squared is 0, because 0 squared is 0. 0 times 3 is 0. Again, by inspection here, you could figure out what x needs to be, what value of x we need to substitute here. So the only way that x minus 4 is going to be 0 is if x is 4. And the same thing here. Yeah, I could solve this equation by inspection. A negative 4 plus 4 is 0. So your solutions would be 0, positive 4, and negative 4. All right, so you could have done this all by inspection. But let's go back over here. So if you did not see right away that your solution is 0, if you had not seen right away that your solution is 0 because possibly the 3 got in the way of you seeing it, then just divide by 3. So remember, you're trying to get x squared by itself first. So right now I'm multiplying by 3. The opposite is to divide by 3. So 3 divided by 3 is 1. 1 times x squared is x squared. And so I get 0 divided by 3 is 0. So at this point I get x squared equals 0. All right, now remember we got to get x by itself. Now at this point you could probably see that the only way that this side is going to equal 0 is if x is 0. If not, then take the square root of both sides. Plus or minus. Now that plus or minus here, when you take the square root of both sides, when you take the even root of both sides, you need a plus or minus. And the square root of 0 is just 0. But notice when I take the square root of both sides, the square and the square root undo each other, I get x to be 0. So some of this you could do by inspection, and you really need to try and see this. You need to try and solve this by inspection whenever you can. And over here I'm going to add 4 to both sides, and so I get, when I combine like terms, I get x to be 4. And over here I'm going to subtract 4 from both sides, and when I combine like terms, I get x to be negative 4. So your solutions will be x equals 0, negative 4, and 4. All right, so there are 3 solutions. So this equation has 3 solutions. All right, number 2. We have 3x cubed plus 2x squared equal 12x plus 8. So 3x cubed plus 2x squared equal 3x plus 8. All right, so what I need to do, since it's not in standard form or general form, I need to bring all the terms to one side. So basically what's happening is, you can put in descending order. So let's just bring these 2 terms to this side, since these 2, since degrees here, the degrees are bigger. So remember, the degree of this term is 3, the degree of this term is 2, the degree of this term is 1, and the degree of this degree of a constant is 0. But what you do to one side, you do to the other. And so I get 3x cubed plus 2x squared minus 12x, combine like terms, equal 8. And then finally subtract 8. I get 3x cubed plus 2x squared minus 12x minus 8 equal 0. All right, so that's where I'm at. All right, so notice that this polynomial has 4 terms. So if you recall from a previous course how to factor this, when you have 4 terms like this, you want to try factoring by grouping. So you're going to factor by grouping. Now the first thing you're going to do, though, just like we did here, is look to see if there's a GCF other than 1. So here, these 4 terms, the only common factor is 1. So the GCF here is 1. So I can't factor out anything from these 4 terms. So then remember, when we factor by grouping, you want to try grouping the first two first and the last two terms. So group the first two and the last two. Now look at the first two. Look at the first group, the first two terms. They both have an x squared as the GCF. So if you're just looking at these two terms, the GCF is x squared here. So I'm going to factor out an x squared. So I get x squared times 3x plus 2. So always check yourself. X squared times 3x is 3x cubed. X squared times 2 is 2x squared. Now over here, remember, since that third term, the sign's negative, you're going to factor out a negative GCF. And so if you look at 12x and 8, the GCF here is 4. So I can factor out a 4. And always ask yourself, now also remember, you got to rewrite it as equals 0 here. Just keep bringing this down. Negative 4 times a positive 3x is a negative 12x. Negative 4 times a positive 2 is a negative 8. And remember, you always want to make sure you can get these factors to be the same. All right, so they're the same, so now I can factor out the 3x plus 2. So I get 3x plus 2 times, and then I get x squared minus 4 left. X squared minus 4 equal 0. So don't forget, you got to say equals 0. Equals 0, equals 0, equals 0. Now, just like before, see how you could factor this further? Remember, you want to factor completely. So you can factor this. That's the difference of 2 squares. This is also the difference of 2 squares. So I can factor this as 3x plus 2 times x minus 2 times x plus 2 equals 0. And then you set each factor equal to 0. So now we're using the 0 factor property. So you're going to set each factor equal to 0. So I get 3x plus 2 equals 0, x minus 2 equals 0, and x plus 2 equals 0. So remember, the 0 factor property says that if you have two or more factors whose product is 0, then definitely one of those has to be equal to 0. That's the only way you can get a product to be 0. One of those factors has to be 0. So over here, now notice that these are all linear equations, so it's easy to solve a linear equation. So I'm going to subtract 2 from all parts, from both sides. So if I combine like terms, it's a 0 right here. So I get 3x equals a negative 2. To get x by itself, right now multiplying by 3, the opposite is to divide by 3. And then 3 divided by 3 is 1. 1 times x is x, so I get x to be negative 2/3. So there's one of your solutions. Over here, if I add 2 to both sides, I get x to be 2. And over here, if I subtract 2 from both sides, combine like terms, I get x to be negative 2. So your solutions are x equal negative 2/3, negative 2, and 2. So those are your solutions. All right, number 3. You have 2x minus 3 equal 8x cubed minus 12x squared. So 2x minus 3 equal 8x cubed minus 12x squared. Okay, so again, I have this polynomial equation, just like number 2. Number 2, we have to put in standard form first. So we have to bring all these terms to the other side. And I brought them all to the left. Over here, I'm going to bring these terms to the right-hand side since the largest degree, the leading term, is on the right-hand side. So I'm going to subtract 2x from both sides. Remember, what you do to one side, you do to the other. Combine like terms. 2x minus 2x is 0. I get negative 3 equal, and put this in descending order, 8x cubed minus 12x squared minus 2x. And then finally add 3 to both sides. A negative 3 and a positive 3 is 0. And I get 8x cubed minus 12x squared minus 2x plus 3. So notice this is in standard form or general form, and it's also in descending order. Okay. Now, most individuals prefer to have the equals 0 on the right-hand side. So all you need to do is just transpose the sides. So if A equal B, then B equals C. So you can just transpose the sides. So I get 8x cubed minus 12x squared minus 2x plus 3 equals 0. All right. So we're going to, again, we have 4 terms, so we're going to group. So factor by grouping. And so I'm going to group the first 2 and group the last 2. And so from the first group, I can factor out a 4x squared. A 4x squared. When I factor out the 4x squared, I get 2x, because 4 times 2 is 8. X squared times x is x cubed, minus 3. So that's what I get, because 4x squared times a negative 3 is a negative 12x squared. Over here, since this sign's negative, I'm factoring a negative GCF. So this GCF is going to be 1. It's going to be 1. So I'm going to write this as 1 times. All right, now you're going to be careful how you write this part. A negative 1 times what is a negative 2x? Well, the answer is 2x. Because a negative times a positive is a negative. A negative 1 times what is a positive 3? Well, the answer is a negative 3. Because a negative times a negative is a positive. Now notice these two are the same, so that's what you wanted. You wanted these two to be the same. So you're going to factor out the 2x minus 3, and you're left with 4x squared minus 1 equals 0. Now remember, you got to factor completely, so I can factor this further because that's the difference of 2 squares. So I can factor 4x squared minus 1 is the difference of 2 squares. Remember how we did this last semester? So that's 2x, that's 1, and so we get 2x minus 1 times 2x plus 1. So that goes here. So I get 2x minus 3 times 2x minus 1 times 2x plus 1 equal 0. And then all you do now is use a zero factor property. So set each factor equal to 0. So I get 2x minus 3 equals 0, 2x minus 1 equals 0, 2x plus 1 equals 0. And then you solve each of these linear equations. So I add 3 to both sides. I get 2x equal 3. So x is 3 halves. There's your first one. Over here, add 1 to both sides. Combine like terms. Negative 1 to positive 1 is 0. 0 and 1 is 1. So I get 2x equal 1. To get the variable by itself, I got to divide both sides by 2, because right now I'm multiplying by 2. So when I do that, 2 divided by 2 is 1. 1 times x is x. I get 1 half. Over here, subtract 1 from both parts, from both sides. So I get 2x equal negative 1. And so x would be negative 1 half. So your solutions are 3 halves, 1 half, negative 1 half. All right, number 4. Suppose we had 2x to the 4th equal 16x. So 2x to the 4th equal 16x. All right, so mistake people make at this point is that because that 16's here, so they see a 2 and a 16, so they first of all want to divide both sides by 2, and you can. I said it's a mistake. Since those are constants, not a mistake, so you can divide both sides by 2. But they overgeneralize with this, and so they also want to divide both sides by x. You cannot divide both sides by x, so can't divide both sides by the variable. Right, so that would be a mistake, a definite mistake, because what happens when you divide both sides by a variable, you get rid of one of your factors, and so you lose a solution. You don't see that there's really another solution. All right, so you lose a factor. All right, so you need to be careful. Now you can divide by a constant. You can divide by a number. You can divide both sides by a number. That's not going to matter. So if I want to divide both sides by 2, I can. All right, so I'm going to do it both ways to show you. But you don't ever divide by a variable. All right, so the first thing we're going to do is we're going to put this in standard form. So we get 2x to the fourth minus 16x equal 0. And then we're going to factor it. So I can factor out a 2x here. So 2x. So I get 2x times x cubed minus 8 equals 0. So 2x times x cubed is 2x to the fourth. 2x times a negative 8 is a negative 16x. Now we're going to factor completely. So remember this right here. X cubed minus 8. That's the difference of two cubes. And so remember how we factor the difference of two cubes. First of all, make sure you see that this is the difference of two cubes. Remember how we did this. So we filled in these parentheses here. So what times itself 3 times is x cubed? Well, it's x. What times itself 3 times is 8? Well, it's 2. So this is the difference of two cubes. And remember what we did was we wrote this as f and L. And so when we factored the difference of two cubes, we said f minus L times f squared plus fl plus L squared. So that's how we factored the difference of two cubes. So your f is x and your L is 2. And so when I factored, and notice I went to the side and did all this, so when I factored x cubed minus 8, f is x and L is 2, I just plug in. So I get x minus 2, f minus L, so that's x minus 2, times f squared. So I square the first. So I square the first. So f is first, L is last. So I square the first, so x times itself is x squared, plus, and then I multiply the first and the last together. So x times 2 is 2x, and then plus, and then I square the last. So 2 times 2 is 4. That's what I get here. Now remember, once you factor the difference of two cubes, see you have a binomial times a trinomial. So we talked about all this in a previous course. So the difference of two cubes is a binomial times a trinomial. This trinomial cannot be factored further. So it cannot be factored further. So don't even attempt to try to factor this. So that goes here. So I get 2x times x minus 2 times x squared plus 2x plus 4 equals 0. Okay, so now I'm going to set each factor equal to 0. I'm going to think of this right here. Although this is 2 is a factor and x is a factor, I'm just going to consider this as 1. So I'm going to set this equal to 0. I'm going to set this equal to 0. And I'm going to set this equal to 0. So I get 2x equals 0, x minus 2 equals 0, and then x squared plus 2x plus 4 equals 0. So I set these three things equal to 0. Notice these two are linear, but this is quadratic. These two are linear, this is quadratic. And remember, no matter what you try, you cannot factor this. Don't even attempt to factor this, because this came from factoring the difference of two cubes. This trinomial cannot be factored. All right, so when I get x by itself, I'm going to divide both sides by 2, and so I get x to be 0. Over here, I'm going to add 2 to both sides, so I get x to be 2. All right, so those two are easy. So I found two of my solutions, one 0, the other one's 2. Now over here, so remember, solving this by factoring is not going to help you because it cannot be factored. So we're going to use the quadratic formula. So use the quadratic formula. This is a quadratic equation. So A is 1, B is 2, and C is 4. So A is 1. Remember, A is the coefficient of x squared, B is the coefficient of x, and C is your constant. And so we plug it into the formula. So x equals the opposite of B. So B is 2. This becomes negative 2. Plus or minus the square root of. And remember the discriminant. So b squared minus 4ac. So b is 2 squared minus 4 times a. A is 1 times c, which is 4, all over 2 times a, and a is 1. So I get negative 2 plus or minus the square root of 2 squared is 4. A negative times a positive times a negative is a negative. 4 times 1 times 4 is 16, all over 2. So I get negative 2 plus or minus the square root of a negative 12 divided by 2. And then I simplify this. So let's go ahead and simplify the square root of a negative 12. So remember, that's going to be the square root of a negative 1 times the square root of 12. 4 is a perfect square that goes into 12, so that becomes, now this is I right here. So I, square root of negative 1 is I. So I get times the square root of 4 times 3, and the square root of 4 is 2. So I get 2I square root of 3. So this is 2I square root of 3. So that goes here. So this becomes negative 2 plus or minus 2I square root of 3 divided by 2. Now you want to simplify as much as possible. So notice that this term, and this term are all divisible by 2. So and also remember you can write these as two fractions. So I'm going to get negative 2 over 2 plus or minus 2I square root of 3 over 2. So this becomes negative 1 plus or minus I square root of 3. Because 2 divided by 2 is 1. Okay, so you have 4 solutions. You have 0, 2, and then these 2. So in my math lab, they're going to ask you to write them separately. So you're going to say x is 0, 2, and then negative 1 plus I squared 3, negative 1, negative 1 minus I squared 3. Or on paper test, you would say x equals 0, comma, 2, comma, and then this right here. So negative 1 plus or minus I square root of 3. Okay, so this one was quite involved, and the reason why it was more involved here was because when you factored, and remember, if you had divided by x, just to remind you, if you had divided both sides by x, you would have lost this right here. So you would have lost one of your solutions. So don't divide by x. Don't divide by a variable. You're going to lose a solution. So when you wrote this in standard form and you factored, you ended up having the difference of two cubes. So you factor the difference of two cubes. So you may have to go back and review your factoring rules. You factor the difference of two cubes and you ended up with a binomial times a trinomial. And then you set each factor equal to 0. And when you set each of these equal to 0, these are linear. So those are easy to get. This is quadratic. So you had to use a quadratic formula. And remember, you ended up with imaginary solutions. So you had the I. And then we're done. So it was quite involved. This one was quite involved. All right, so that's going to take care of the part 1 of solving equations. So polynomials, equations by factoring.